safety engineering was like an ocean class that you guys might remember. Ocean safety is the thing that makes you put all this yellow lines on the floor and stuff. You'll see it. You'll see the plants. So learning the rules of that. After that, I worked at Reynolds Packaging Crews, which is Reynolds aluminum foil in Louisville. They actually spool all the aluminum foil pretty much in the entire country. They make all the stuff for Target, for Piggly Wiggly, all those off-brands are all done at Reynolds Packaging. And they've got all these machines called spoolers and everything else that spin. They grab the aluminum foil that's already been built down to a small state, and grab it and put it on those cardboard rolls and spin out 100 square feet, 250 square feet, whatever size box you buy. And then they cut it off and then they push it into a box that has that little blade on it, and then they tape the box shut or glue the box shut. And while it's doing all that, all the electronics that are telling it to push and move and spin are keeping track of how many rolls they've done, how many feet they've done, how many they've cut wrong and had to discard, how many boxes they've made. Something's keeping track and keeping all that in memory. So my job was as a data integration engineer. I had to program a big server that went in and talked to all these machines. They had like 28 different spooler lines and a bunch of different boxing lines. They would talk to all these machines and gather information about how many of the product you've made in a day, which machines are having trouble, which machines are going slow, it might need some maintenance, and it would put those in all the reports and things. And I did that for a little over a year. I liked it, but it got really repetitive, and I'm working with the same machines every day. Got a little bored with that. So I thought, why don't I go try to find a job where I can actually design something, I can build something, and implement ideas and problem solving. So that's what my job in magnetics is now. Well, it was before a couple months ago. Is customers would call and they would ask, what am I doing wrong with this magnet? Isn't working right? Or I would like to do this with a magnet. How can I do it? And I'll design something for them based on their exact needs, what temperatures the magnets are going to be at, what's going to be in their environment, how caustic it might be, how much they're willing to spend, all sorts of stuff. Take all those variables and try to design something for them that work. And that's where a lot of these products came from. Every one of these products has something to do with magnetics. The current aspect of my job, I just switched over. I'm working with a consumer electronics company in Silicon Valley from the same magnetics manufacturer, and I'm doing a lot of research and analysis for them. So we're trying to come up with new materials, mostly what we call soft magnetic materials. They're not permanent magnets like these. They're the materials like this quarter that the magnets are sticking to. And the better you can make those, like steel that a magnet sticks to, you can make specialty mixtures of steel that will channel that magnetic flux better, and that's what we're researching and doing. So that's a lot of my job now. So I'm back and forth from California quite a bit. I just got back from China last Tuesday. I went over there and saw some of our manufacturing facilities. So I've been to Boston, I've been to Texas, a bunch of different places where I've given magnetic lectures to design engineers to tell them how to build with magnets, what some of the downsides are, some of the best practices, things like that. So if you get into some of these fields, a lot of travel might be involved. I like to move around a lot, travel. I like to move my house. I've been at home for 10 years, but I do like to travel and see new things. So I try to find a job that would ship me off places and let me run around. So that's good. I get to meet new people and do things. Anybody have a question about any of that stuff? Yeah. I have not been to Europe. No, I've been to China, 2 different cities in China. Actually, I spent 5 days in Hangzhou, they call them Tongs, little suburbs of a city of Tonglu. And I spent 2 days in Shanghai, which is the biggest city in the world. It's got 24 million people, which is 3 times the people of New York City. So it was quite different. But no, I've never been to Europe, or not yet anyway. If I can find a customer over there, I will. Yeah, I went over a couple of cities, but not to Europe. So that's good. I get to travel and meet new people as part of the aspect of that. That's a lot of fun. Some of the other stuff I've worked on, I've done computer programming, mobile programming, any of that stuff, all sorts of computer science aspect. Electronics design, I'll show you one of the electrical devices that we designed and built for a company one year. But, and then an electrical spinal stimulator I talked about. Those are some of the other big ones. So I can answer questions about a lot of areas in science, but really I'm an engineer. I went to engineering school. I had a minor in physics, and I've taken a bunch of other sciences. And I'm doing more research now. I'm doing more scientist work than I am engineering work, but that's what I am. So I'm going to focus this probably more towards engineering. If you have other questions, I'll be happy to field them and see what we do. So what is an engineer? An engineer is really a person that takes science, math, any concepts that they can find, and applies them to the real world. we're trying to create a product, we're trying to solve a problem using some of these theories that somebody else has developed. So a lot of times we're not doing groundbreaking research as an engineer, you're implementing somebody else's research. But you can also come up with new devices and inventions. They just usually use theories that some physicist or somebody else in science has come up with. So science and engineering are very tied together. And math, so much math. You'll want a heavy background in math. Has anybody thought about going into engineering or in science? Mechanical engineering, that's one of my favorites. Any other biology, microbiologists, physicists, anything else? Mechanical engineering is a lot of fun. I actually was a large portion of my product design stuff. Instead of using my electrical background, I had to design actual mechanical fixtures and tubes for people, for car companies. Like I said, Ford has 2 very large plants in Louisville, so I do a lot with them because I can physically go there really quick. I can just drive over there and see their new production lines and their new facilities, find out what the problems are. I can get stuff done a lot more quickly if I don't have to fly across the country to do it. So I've done quite a bit of work. But I've also worked in Honda plants. I've been in Subaru plants, all sorts of different places. But yeah, that's really what engineering is we're designing some application. We're solving a problem, really is what it is. Whatever theory or math it takes to build something that solves the problem and does it quickly and efficiently. So what can you really do with one of these degrees? This applies as well to science as it does to anything in engineering. One of the big ones, especially for Kentucky, is maintaining machines, equipment, retrofitting equipment. Because we have such a large amount of space, we have a lot of industrial plants. We make a lot of products. I'm sure you guys have seen, I think there's like a Toyota plant right now, we're in 237. Yeah, there's a lot of large plants that do a lot of automated and manual manufacturing. So a lot of people on an assembly line, and somebody has to design the movements that those people do, the products that they put on the car, everything else, even the rivets on the Fuji, there's a Levi plant here too. The chemicals that they use to dye, somebody designs all those, and those are typically engineers. But inside the plant, there's machines that wear out, that are getting old. These companies don't like to build or rebuy $1 billion machines when something breaks. They want to have them built, they want to have them rebuilt, retrofitted to do more functions. So there's a lot of engineers in those plants that I'll go through, and their big job is just maintenance and fixing and getting machines set up for the newest line of product. Another field is technical sales. There's several different types of salesmen, but technical sales is a very specific one. Usually they'll hire an engineer for this because they'll know how the whole system works. It's easier to sell something to somebody if you can explain it in great detail, any questions they have. And usually this would apply to selling some sort of machine or something to an industrial environment where they're going to have a team of engineers asking questions. You're going to want to know the answer. You can't just be a guy walking around with a pamphlet. You have to actually know what they're doing and how that machine might benefit. Technical sales is a good one to be in. If you're a really good people person and you can understand the math and everything behind it, that's great because usually they're commission-based. You can make a lot of money doing technical sales. Our magnet industry actually hires a lot of freelance salesmen that make quite a bit. They don't pay them anything except the commission on what they sell. So if they're really good people, persons that have ends at different companies, they can make a lot of money that way. Think tank problem solving, consultants, freelance engineering, stuff like that. A lot of companies have their own think tank areas. They'll throw you basically in a room and give you a vague problem and say, come up and figure out how to do it. And you'll have 3 or 4 engineers in a group or whatever, and you guys are coming up with all sorts of strange and weird ideas. A couple people from the science backgrounds will be in there if they have a physicist on staff or whether they're chemical engineers. Throw everybody in there and just throw a bunch of money at it and see what you can build. It doesn't have to be good, it doesn't have to work well, it just has to work. And they'll come up with something new, and then they'll patent it, and then they'll try to build it efficiently and make it cost effective. But the people in the think tanks are just throwing ideas around, and sometimes that can be fun and a little crazy. A lot of stuff doesn't work, and it's a lot of wasted money, but that's why companies have big R&D groups and big research and development budgets. The big one that most engineers are going to fall into is probably device design. You're going to design either devices, be it electrical or mechanical or anything else. Objects, I would call my magnetic circuits probably objects. Chemicals, there's chemical engineers that are making paints, solvents, all sorts of different chemicals and dyes and everything else, or water resistant, like Rain-X water resistant microbials that'll go on a window. There's all sorts of chemicals. Software design, different programming, structural design, that's buildings, bridges, all sorts of different engineering. Pretty much any product or anything that's being made has had some sort of engineering touch to it. Another big one is analyzing current designs. You want to make them as efficient as possible. So that's one of my big jobs with my FEA software is I'll take somebody's magnetic design and I'll pick a different material, either to maximize cost or to make it a little stronger, tell them how much pull force they have. And I'll use software for that called FEA, which is finite element analysis. It'll take my 3D models that I built in the computer and put them in this virtual environment and build this cloud of points around it, just little points everywhere. And it will do all the math at each of those points and then add them together or do whatever I tell it to at all those points to decide how strong that magnet is, what temperature it's at, how much damage is being done to it. And it'll do all that math and spit it out for me. And that's a great way. That'll allow me to do hundreds of designs at the time it would take me if I hand to do one. So I could run through and say, well, if I use this material or made the steel this thick or changed this distance somewhere, would that make my final product more efficient? And I can have it go through and run hundreds and hundreds of these design examples until I find the one I want. Technical writing is a big one. I enjoy that. It's really different. Think of any device that you have. You've got an instruction manual for it. Some of these bigger machines that you sell to industrial suppliers and things, we're going to have really big technical manuals, just whole books. And some people don't like to write in the standard sense. Usually when you write to be interesting. You write to get an idea across. You have to come up with different adjectives, different words. Use a thesaurus sometimes to pick out the best word for it. None of that really applies to technical writing. You just write the facts as simple and brief as possible. You write exactly what a system's doing.
Sorry.
And that works for some people. Some people like to get ideas across that are they're logically brained. They're really good at just writing how something works and why you want to use this machine or what this function does of it. And you'll write a big technical manual based on that. So technical writing is, even places like Microsoft Hire, they've got a whole developer network that just does technical writing and writes on this research network and you can do searches on it. Implement machines. A lot of times when you sell somebody a machine, you'll send somebody to their facility to hook it up, to integrate it with their other machines, to basically get it talking with their system. Typically we call that a technician, but a lot of engineers will do that style of work. Quality control. Quality control is a really big one. I actually dealt with that team a bit because I designed these magnets. Somebody has to test them and make sure that they're the exact size that I told them I wanted, or the exact strength that I told them I wanted. And if they're too weak or too strong, they have to kick them out and order some new ones. So we have quality control that does that, and every company who sends out a product has a quality control team. Somebody that looks through and makes sure that whatever you're building, whatever you're designing, is as big as it should be, operates the way it's supposed to, because customers really don't like it when you sell them something that doesn't work. So it makes them not want to buy from you again. So we have these big teams of people that go through and decide if something's good enough to ship out or not. And I have to deal with them a lot because I have to make the test for these magnets that they run. And the final one I'd say is designing somebody else's product. You've already got a product, you've got a finished design, and you're trying to make it better, more efficient. My example for this is usually cell phones. Every year, the cell phones are doing the same thing, but every year, every 3 months, every 6 months, we come out with a new design that's got a bigger screen, it's more power efficient, it's got more features, it's got a better camera. Somebody's taking these old designs and making them better. They're actually doing it concurrently. A lot of the big companies like cell phones are running them several concurrent design phases. So the cell phone that's coming out next year might almost be done. Then they have to set up the machines to build them and put them together and all the quality control standards. There's already people, there's a whole team just as big working on the cell phone for 2 years from now that are just putting together the boards and the ideas and testing them in the lab before they go into manufacturing. So they're already thinking several steps ahead trying to make these devices. Even before they've seen if this one has good features and is selling well, they're already designing the next one. And that can be an interesting area because sometimes you use a product and think, hey, this could be better. I would like it to do this instead of that, or it's missing a feature or a button that I want. There's always somebody rebuilding somebody else's design. And these are a lot of the same jobs that apply in like a biology lab, or a lot of the companies hire chemists and biologists and things to create new products. I think there's a soft drink company somewhere in the area that makes flavors for soft drinks. And they're like actual the syrups that they put in some of them and new artificial flavorings that you put in your food products. They hire a lot of biologists and chemists that'll do these same type of design phases. And they have different sales teams that have to know the products. This applies to a lot of science. Does anybody have any questions so far? Anything sound interesting? Hey, I want that job. I know it's kind of boring if you just second out there, but it is a lot of fun to actually build something. I got really sick of seeing the same set of machines over there. To do some of these things, you do have some education requirements. A good way to get a job is always experience. It's really hard without the experience to get a job, even if you have the exact degree that they're looking for. If you're not experienced, they're going to have a hard time hiring you because there's somebody else more experienced they could hire. U of L has a great engineering program, I think. I really enjoyed it. They have, for your bachelor's degree, you have a mandatory 1 year of full-time work experience. So you've been at a company, you've done actual engineering work for an entire year. And that allows you to have a year of experience when you come out. So usually you come out with a master's degree and a year of experience. Because of that, we have a 99% placement rate, so 99% of people get a job right out of college. Not a lot of other places can say that. But that applies to all sorts of scientific fields. Even if you don't have a co-op program as part of your program, you can find during the summers, during the evenings, whenever you've got time, you can intern or co-op at a lab or in your own science lab there in school, or any of the other areas, jobs in the area, even if it's part of the office work, just to get part of the experience of being in that environment. And that can be really helpful in getting a job. I mean, you guys probably hear a lot about people coming out of college not being able to find work. So that doesn't happen as much in science and engineering as it does in other fields, but it's still a very real thing if you don't have the experience to get a job. As far as what you'll need to get through college or get to college for an engineering or science degree, high school is a great place to start looking at this. You need a lot of math, especially engineering, but all science needs a lot of math. That's how I got into it. I was really good at math. It's been my favorite thing, but I was really good at it. So I stuck with it. I'm 8 or 9 math classes past calculus in engineering. About 7.5 you can go. So you guys will have options in high school that'll push you a little further towards that. And they're not necessarily stuff you would normally take. Everybody has to take Algebra 1 and geometry and all that fun stuff. But calculus is completely optional, and you have to set up early your track that's going to lead you to be able to take calculus. Physics is a big one. And not everybody has to take that. Not everybody should take that, but if you like math and you enjoy that logical problem solving things, I highly recommend it because it'll put you on a good science path for later. I think you guys are all going to be required to take biology and chemistry, but if you really enjoy those as well. Psychology, sociology classes, you're probably going to touch on that in high school as well. That'll put you on a good path for science and